Après cette vision européenne, en quelque sorte, nous avons envisagé la vision américaine. Et professeur Sutherland. Donc John Sutherland est professeur et Feisenfeld Family. I don't know what it is, but it doesn't mean. Donc directeur du département d'ingénierie environnementale et écologique à l'université Purdue. Il est à Purdue depuis 2009 seulement. John a une formation en génie industriel, puis un doctorat en génie mécanique à l'université de l'Illinois à Urbana-Champaign. Et il a travaillé 5 ans en industrie, puis démarré sa carrière à Michigan Technological University, où il a occupé différentes positions pendant presque 20 ans. En particulier, il est le directeur de l'Institut des Sustainable Futures. Pas de French translation for that. Voilà. Donc, John Sutherland est l'un des chercheurs qui fait autorité dans les problèmes de sustainabilité appliqués à la conception, à la production et en gros à toutes les problématiques industrielles. Donc, il va plutôt nous présenter la vision donc américaine des systèmes de production. Thank you.
Thank you. Good morning. I'd like to thank thank you all for having me here today. It's really a great opportunity to talk a little bit about manufacturing in the U.S., and I will focus on sustainable manufacturing where appropriate. I might also add that as a prelude to my discussion this morning, that I was able to secure input from many different sources for this presentation, and as Professor Westcamper said, I will leave a copy of my presentation behind because there are many abbreviations, much detail, far too much for a half-hour presentation. So, whoops. So, as is often the case when we talk about sustainable manufacturing, it's important to begin with the definition. There's really 2 parts to this definition. Number 1, we need to think about products in terms of their environmental impact. Are they using a minimum amount of resources? Are they producing a minimum amount of waste? And of course, the second part of sustainable manufacturing is the environmental footprint of the process, the manufacturing system, the supply chain, and again, thinking about minimizing the environmental impact of that processing and supply chain dimension. As Professor Westcamper indicated, not only in Europe is manufacturing important, it's very important in the U.S. It's a high level of employment. The multiplier in terms of jobs created through manufacturing is very large. It's a significant portion of the economy, creates more than half of the U.S. exports, and it is something that has received a great deal of attention in the U.S. over the last 7 to 10 years. I've divided my presentation into 3 pieces. First, it's a focus on what is the government doing, programs and activities. Secondly, we'll talk about some of the activities within universities around the United States. And then thirdly, some select industrial activities that are also related to sustainable manufacturing. So, beginning in about 2007, President Bush issued an executive order. An executive order is an activity, and I don't want to get too bogged down in the U.S. Politics and administration, but essentially an executive order is something that the federal government can require of its suppliers. So in 2007, President Bush issued an executive order that related to manufacturing. In 2009, President Obama issued an executive order that related to environmental leadership and energy. and that, of course, impacts all the suppliers to the federal government. There was a law passed in 2010 that talked about developing sustainable metrics, or sustainability metrics, and practices for manufacturing. In 2011, the President's Council for Advisors in Science and Technology, we call it PCAST, called for the establishment of an advanced manufacturing partnership, the AMP, and 1 year later in 2012, the AMP essentially talked about establishing a number of activities to support manufacturing in the U.S. These included the National Network for Manufacturing Innovation, which essentially would establish 15 institutes for manufacturing innovation to be funded by $1 billion in support from the federal government. It established an Advanced Manufacturing National Program Office, and again, the abbreviations are just too numerous here to get involved with, but the AMNPO is the Advanced Manufacturing National Program Office. It's essentially there to coordinate activities within the federal government related to manufacturing. It called for, this AMP called for the establishment of MDFs, manufacturing demonstration facilities. It also talked about creating hubs of technology as well as instituting various education and training programs. And of course, within the federal government, there are a variety of agencies, a variety of departments, and I'll try to talk a little bit about some of the activities that they are pursuing in support of manufacturing. So we are, of course, very familiar in manufacturing with this gap between fundamental research that goes on at universities and then what the private sector oftentimes needs. We call this the valley of death. I believe the Fraunhofers were established in Germany to try to bridge this gap. A lot of the manufacturing programs that have been proposed in the U.S. are meant to try to fill this gap as well. These NNMI, National Network for Manufacturing Innovation Institutes, essentially that plan calls for a number of these institutes which will work to fill this gap. Of course, ultimately, as Professor Westcamper said, we're interested in providing employment, high value, high quality manufacturing jobs, try to do things to reduce the unemployment rate, and of course enhance the competitiveness of the U.S. And here on the left you can see all these parts of the federal government that they hope to engage in through these institutes and through these manufacturing demonstration facilities to bridge this gap. So this is, we say in the U.S. an eye chart, too small to read unless you have very good glasses. This past fall they established the first of these institutes. That's here in the center, the NAMII, National Additive Manufacturing Innovation Institute. It is focused on additive manufacturing. It's bringing together a number of companies, the government, standards organizations. Over here we have the research universities. I believe these are the supporting more, we say community colleges. And of course, up here, what is that? No, the technology developers. This was all funded with $30 million from the federal government through the DOD, the Department of Defense, and the Department of Energy. The expectation was that companies that would be engaged in this would at least match these monies. So the government expects industry to step up and contribute to this activity. Within the Department of Defense, there are a number of other programs, and I've just highlighted here that the Department of Defense spends a significant amount of resources on environmental programs. And in support of sustainable manufacturing, the Department of Defense has established a number of different activities. These include SAMI, Sustainable Aerospace Manufacturing Initiative. There's one called MERCY. It's again focused on sustainability across the supply chain. Here's one focused on sustainable manufacturing cells, and again using digital simulation, digital factories, digital products, thinking about the use of advanced tools and simulations to be more sustainable. Over here are some highlights of some of the good things that are happening in the U.S. A lot of the partners now are thinking about green, about being sustainable, which is a big transition in the U.S. People are more and more thinking now about life cycle assessment. Within the Department of Energy, there are a number of activities. They have these, what they call hubs. There is one hub focused on battery and energy storage. It's funded to the tune of $120 million over 5 years, looking to develop better battery and energy storage devices. I believe the lead organization on that is Argonne National Labs. One of the other hubs here is Critical Materials Institute. This is led by Ames Lab. My university is partnering on that activity. It's focused on rare earths and trying to, in our case, close the loop on some of these products that have rare earth elements. The first manufacturing demonstration facility is at Oak Ridge National Lab. It's focused on additive manufacturing, and they envision many other of these facilities focused on different manufacturing technologies. Within the DOE, they established recently an industrial assessment center activity, which basically is run by a university and meant to serve the needs of small and medium enterprises. The Department of Energy also has a program here that's called Better Plants, and essentially they're focused on trying to help, again, most often these small and medium-sized enterprises to be more energy efficient. Within the Department of Education, there is a program called the Graduate Assistance in Areas of National Need, GAN, and essentially this is a multidisciplinary. Professor Westcamper mentioned this. More and more we have to think about these complex problems. It requires multidisciplinary thinking. And so this GAN program essentially seeks to serve that need. It seeks to create a new source of doctoral students, PhD students that can help the U.S. Essentially maintain its competitive position in terms of science and technology. Also meant to serve as a national education model. You know, each of these little success stories can then be used by other universities as an example, and I've just listed some of the GAN activities that are there. You can see that, you can see that some of these are focused on things like using MEMS and NEMS technologies to support batteries and motors. There's an activity at the University of South Florida focused on the sustainability of water, energy, and materials, just to name a few. So one of the things that we often hear in the U.S. is that the unemployment rate in the U.S. is 7.9, 8%, close to 8%. But there are, I've heard anywhere from 1 to 2 million jobs available that are unfilled because the people are not there with the appropriate skills, the appropriate training to fill those jobs. So there are a number of programs underway in the U.S. to try to meet this goal, meet this need. I've just listed two here. One is this TAACCT. Essentially, it's an effort to invest $2 billion to help community colleges. So this is not universities, not high schools, but more training schools, better prepare students to enter the workforce. There's also a Jobs Accelerator program with some modest investment to try to help public-private partnerships again meet this skill gap. One of the parts of the Department of Commerce in the U.S. is the National Institute of Standards and Technology. It has a sustainable manufacturing program. Some of its activities are listed, and they are looking at things like life cycle engineering, ICT, systems engineering, modeling and simulation, standards, of course, because it is the National Institute for Standards and Technology. NIST also has what they call this Manufacturing Extension Partnership, a number of different centers throughout the United States with the goal of each of these centers serving the companies in its region. Technical issues, oftentimes training needs, trying to meet those needs. NIST also has a green supplier network that it works with. So many activities that are underway. So in the U.S., we have a number of folks that are involved in sustainable manufacturing. It's not just me. And so these are some of the universities around the U.S. that have significant sustainable manufacturing activity. I've listed some of the key faculty at these universities, and these are only some select people. Different places in the country, different emphasis, different expertise. Just to give you some feeling for the types of subject areas that are being addressed in the U.S., I've listed these areas here, anywhere from green chemistry, sustainable technologies, DFE, design for the environment, design for sustainability, environmentally conscious design. There's many people looking at nano manufacturing, sustainable electronics, remanufacturing and recycling, life cycle analysis or life cycle engineering. Of course, education. We're universities, right? So that's another important topic. Much of the research in the U.S. is funded by the National Science Foundation, which is part of the federal government. So I wanted to talk about some of the things that the NSF is funding. One of the pieces of the NSF is CMMI, and you can see what the abbreviation is. I think during one recent fiscal year, you can see the amount of money they spent. Here's another program. Here's one, EFRI, Emerging Frontiers in, research and innovation. And again, some modest amount there. Here's another one, Industrial Innovation Partnerships. But some specific activities related to sustainability include this SEES, which was funded to the amount of $202 million. Here's another one, Clean Energy, $350 million, Advanced Manufacturing, $150 million. And NSF has been very good about establishing centers in several areas. Chemical innovation, so here we can see a center that they supported, Center for Sustainable Materials and Chemistry. Here's one on sustainable polymers. In the materials area, we have Center for Emergent Materials. There's also one on renewable energy. And then nanoscale, lots of nano activity in the U.S. Center for the Environmental Implications of Nanotechnology. And here's another one. So I have some selected detail on a few of these initiatives. Here's a colleague, Jackie Isaacs from Northeastern University. She's looking at the application of LCA to nanomanufacturing, essentially to guide the development of nanoproducts, nanomaterials, and using LCA as a tool, life cycle analysis as a tool. Here's a colleague of mine, Rob Annex from the University of Wisconsin. He's looking at the consequences of biomass-derived materials for production of energy, fuel, and other products. And again, all the implications, the economic, the environmental, the social. Along the more traditional line, here's a colleague from Penn State, Fred Cannon, and Fred is looking at improving the environmental footprint of casting, essentially looking at different strategies for reducing the environmental impact of some of these casting operations. This is the one that is at my university. I put the nice picture on this page of Dr. Handwerker, Professor Handwerker, rather than putting my picture up there. But Professor Handwerker is essentially leading this effort, and we have one project that is looking at improving the sustainability of electronic products. As I indicated, we're working with Ames Lab on this Critical Materials Institute, which is focused on addressing some of the challenges associated with rare earth elements, which are vital, many aspects to the U.S. industrial activity. So just a few examples of some of the industrial activities that are underway, and I wanted to leave time for questions as well. Here are some selected industry associations, and again, there's many industry associations. The EIA, INEMI is the International Electronics Manufacturing Initiative. We have the National Association of Manufacturing, AISI. So these are all just a select group, and I wanted to talk about some of the activities that they've proposed. EIA is looking at essentially talking to consumers, educating consumers about recycling and reuse opportunities for electronics. INEMI, actually we work at Purdue with INEMI, and they're essentially trying to do more in terms of HFRs, essentially trying to remove some of these nasty substances out of electronics. NAM, which is a very large organization in the U.S., has established a sustainability task force. AISI, American Iron and Steel Institute, they have an innovation and recycling program. So again, many organizations are now talking sustainability. When I first got involved in kind of the sustainable manufacturing area back 20-something years ago, no one talked about sustainability in the U.S., so it's very, very nice nowadays to see many organizations looking at it. I wanted to just talk a little bit about some of the activities that a few companies have underway. Lots of times with companies it's difficult to try to glean from their websites some of these exciting things that they're doing, but we were able in some cases to find some of those activities. So on the aerospace and defense front, Boeing essentially is trying to reduce some of the nasty substances that they have in their military aircraft. I wasn't going to put anything about the Dreamliner on there. I thought that might be exciting. It's kind of exciting that they're pursuing the 787, but they've had some problems recently, so I decided to not put that. Lockheed Martin is working on reducing water consumption. HP is looking at BFRs, brominated flame retardants, and working to eliminate those. And of course, they're trying to come up with better designed products. Here we can see EMC. They have a new disk drive that uses less energy per operation per second. Again, focus on energy. Johnson Controls, again, strategies to improve efficiency, to improve things, to reduce greenhouse gases. Goodyear, better tires. Intel's working on greenhouse gas emissions, trying to improve their energy efficiency. Applied Materials has worked to cut their CO2 emissions. So we have a number of these companies that are trying to be more energy efficient, better products, less greenhouse gases. Emerson, working with their customers on CO2 emissions. Thermo Fisher Scientific has a new meter that's better in terms of energy. Eaton has worked with Airbus on saving some weight through a new hydraulic and fluid conveyance system, which saves on fuel. And then a few other miscellaneous examples. And this ranges all the way from trying to cut emissions with cyclopentane in a General Electric example to a case of Procter & Gamble using renewable material in one of their hair care products. So, a few summaries. There's a lot of activities going on in the U.S., wide range of programs and activities. Within the federal government, universities are responding, industries are responding. When I kind of step back and look at what industry is pursuing, it tends to be focused on energy reduction, cutting CO2 emissions, increasing attention to the life cycle. When I look at all the activities underway in universities, lots of emphasis on nanomanufacturing, lots of emphasis on biomanufacturing, specifically looking at renewable materials for energy production. With respect to the federal government, we've seen the emergence of moving from executive orders to actual acts and laws passed by the government, and now we have this national network for innovative institutes, manufacturing institutes, as well as manufacturing demonstration facilities. I think collectively what I've seen emerge here over the last 5 years is kind of a coming together of the government, universities, and industry to help the U.S. kind of reinvigorate its manufacturing activity. Just a few acknowledgments of some of the people that contributed here. Bruce Kramer from the National Science Foundation. I was able to secure some input from Ralph Resnick, who's leading this NAMI, National Additive Manufacturing Innovation Institute, and his colleague John W. Sudarsan at NIST, Mike Molnar, and Rob Ivester from the Advanced Manufacturing National Program Office, as well as Tony Tubiolo, and then some colleagues of mine from Purdue. Thank you.